morning, everyone. I'm Kyle Manuel O. Frias, and today we're going to solve some physics problems from Chapter 25, Current Resistance and Electric Potential, problems 25.36, 25.38, and 25.40. First problem, easy. If a 90-watt bulb, as you can see at problem 25.35, which I put below, is connected across a 220-volt potential difference, how much power does it dissipate? So we're asked to find the power. So the first step that you're going to do is list the given values. So the first power is 90 watts, the volts 120 volts, and the resistance is missing, and the power of the other system, which is what you're trying to find, is missing, and its volts is 220 volts. So we're gonna use the power formula, which is P is equal to volts times the current, and then since we don't have the current, we're just gonna use the Ohm's law, or we're just gonna derive from V is equals to Ri, and then it will become to I is equals to V over R. So you just substitute it to the given formula to P equals to VI, and then you're gonna get P is equal to V squared over R. So since we know the formula for both of the powers, we're just gonna get the ratio between them. And as you can see, when you divide the two powers, you're gonna get P naught is equal to P times V naught squared over V squared. So after that, you're just gonna substitute the given values in that formula. So after substituting the given values, you're gonna get 302.5 watts for the power. Next problem. A battery-powered GPS receiver operating on 9.5 volts draws a current of 0.14. How much electrical energy does it consume during 1.7 hours? So we were asked to find the electrical energy consumed after 1.7 hours. And as usual, we're going to list first the given values. 9.5 volts, and the current is 0.14 amperes, and the time is, after you convert it, it will become 6,120 seconds. And the formula for the electrical energy consumed will be energy is equal to voltage times current times time. So since none of the values are missing, we just substitute the given values to in the formula, and then you're gonna get 813 joules, 813.96 joules. So last problem. Electric eels generate electric pulses along their skin that can be used to stun an enemy when they come into contact with it. Tests have shown that these pulses can be up to 502 volts and produce currents of 790 milliamperes or even larger. A typical pulse lasts for 10 milliseconds. What power and how much energy are delivered to the unfortunate enemy with a single pulse, assuming a steady current? So we were asked to find the power. So as usual, we're gonna list first the given values, which is the volts equal to 502 volts. The current is 0.079 amperes. The time is 0.01 seconds. And the power formula is just equal to P is equals to IV. And in order to find the joules or the energy consumed, since it was asked it was asked at question B to find the joules or the energy consumed, we're just gonna get from the power, which is the power formula, which is just the joules divided by time. So you just use algebra in order to focus the equation into finding the joules, which is what you want. So you just times the time by the watts, or in other words, the energy is equal to power times time. So you're asked to find the power. So we just simply use the power formula, which is P is equal to IV. So we just substitute the given values in that formula. So it will equal to 39.66 watts. So for letter B, we're asked to find the energy. So since I explained it earlier, we're gonna skip to the the equation part. So the energy is simply, and E is equal to power times time. So since we already found the power earlier at problem A, we just substitute the given values as usual, and then you just multiply 39.66 by zero point zero 0.01, and then you're gonna get 0.3955 joules for the energy consumed. Thank you for watching, and God bless you.